everyone, and a huge welcome to all the new safety officers joining us for this explainer. Seriously, you're stepping into one of the most dynamic, critical roles on any construction site. Today, we're diving deep into the anatomy of an excavation. Because, well, here's the absolute truth about digging into the earth. You are constantly battling gravity and completely hidden hazards. The second you break ground, you're altering a natural balance, and the earth, it's always going to try to fill that hole back in. It's your job to make sure that doesn't happen while someone is standing inside it. So let's get you equipped with your essential blueprint for survival and safety.
All right, here's our game plan for today. We'll start with 1, what is excavation? Move into 2, protective systems. Cover 3, soil types and sloping. Tackle 4, identifying hazards. And wrap up with 5 essential precautions. Okay, section 1, what is excavation? At its core, excavation is really just the removal of earth. But as a safety officer, you've got to look closely at exactly how that earth is being removed, because how you dig completely dictates the initial risks you're going to face. We categorize this strictly into 2 methods. First up is manual excavation, which relies entirely on physical manpower. Second, we have mechanical excavation. That's when you bring in the heavy machinery, like excavators or JCBs. If you're running a JCB, you are dealing with massive force, dangerous blind spots, and heavy equipment vibrations. But if you're using manpower, you're looking at entirely different physical vulnerabilities. Pinpointing the method is literally your very first step in assessing the risk.
Moving right along to section 2, protective systems. So when you're securing a trench, your primary defenses essentially boil down to 2 distinct philosophies. On one hand, we have shaping the earth. This involves sloping, which means cutting the trench walls back at an angle, and benching, where you create these multi-tiered step-like levels on the sides of the pit. You're actually physically changing the geometry of the earth to stabilize it. But on the other hand, what if you don't have this space to shape the earth? That's when you pivot to holding back the earth. You'll use shoring, installing temporary structural supports like hydraulic walls to physically prevent cave-ins. Or you'll use shielding, like dropping in massive, heavy-duty trench boxes. Now, shielding doesn't necessarily stop a cave-in, but it creates this incredibly secure armored workspace, so your crew remains completely safe even if the earth around them gives way. Which brings us to section 3, soil types and sloping.
You absolutely must understand the math behind soil classification. Because, let's be real, not all dirt is created equal. We categorize soil based on its compressive strength. Type A is your most stable, cohesive soil. Think of really dense clay. It boasts a compressive strength of over 1.5 tons per square foot. But even with all that strength, it still requires a sloping angle of 53 degrees. Then there's type B, which is a bit less stable, sitting between 0.5 and 1.5 tons per square foot, requiring a flatter 45-degree angle. And then we have type C. This is your unstable, loose stuff. Sand, gravel. It has a strength of less than 0.5 tons per square foot. It literally cannot stand on its own without protection. If you're sloping type C, you have to lay it way back at a 34-degree angle, or just use heavy shoring. Finally, you've got stable rock, which is the only thing that can be cut perfectly vertical at a 90-degree angle. The big takeaway? Never ever assume the soil is safe just by looking at it. Classify it and slope it according to the math.
All right, section 4, identifying hazards. Danger in an excavation, it doesn't just come from one direction. It is a total 360-degree threat. Yes, a wall cave-in is a massive, terrifying danger, but what about what's underneath you? Striking underground utilities can instantly trigger electrocutions or huge explosions. And look above you. What happens when that tall, heavy machinery accidentally bumps an overhead power line? Then look at the edges of the trench. Removed soil, raw materials, or even just a heavy tool sitting on the edge can easily get kicked right back into the pit onto your workers. Oh, and we definitely can't forget environmental wildcards, like sudden flooding. Water accumulation drastically weakens the soil in minutes. Plus, even nearby structures can completely collapse if your digging compromises their foundation. You literally have to keep your head on a swivel here. Danger is above, below, and all around. Now, I really want you to burn this specific number into your brain, 1.2. Once an excavation hits just 1.2 meters in depth, which, by the way, is barely chest height for an average person, the rules of the game completely change. At 1.2 meters, that excavation officially transforms into a confined space. This immediately triggers the risk of toxic gases, which absolutely love to sink and settle in low areas. It also means you now require dedicated, highly specific access and egress protocols. It's no longer just a hole in the ground, it is a strictly regulated environment. Which naturally leads us to a pretty pivotal question. with risks ranging from invisible toxic gases pooling at the bottom to massive walls of earth threatening to cave in to live utilities buried just out of sight. How do we actually lock down and secure the site? Let's shift gears from the terrifying problems to your actionable solutions. Section 5. Essential Safety Precautions. Listen, before a mechanical excavator's bucket ever even scratches the dirt, you have to follow this mandatory, life-saving sequence for dealing with hidden underground utilities. Step 1. Check the area installation drawings. You have to know what's theoretically supposed to be down there based on the blueprints. But Step 2. You never just trust those drawings. You dig a manual trial pit. You use physical manpower to carefully, slowly expose what's actually in the ground. And Step 3, once you locate those live facilities or utility lines, you mark them out incredibly clearly for the entire site to see. Only after you've nailed this rigorous process do you even think about bringing in the heavy machinery. As for your daily physical site controls, think of it like building a fortress. You need hard barricading and highly visible safety signs around the entire perimeter to prevent falls. If there's a road right nearby, you've got to set up alternate routes to keep those heavy traffic vibrations far away from your trench walls. To fight off water, you build earthen bunds around the edges to stop surface water from flowing in, and you keep water pumps on standby to clear out any sudden accumulation. You absolutely must provide safe access and egress points. And remember that 1.2-meter rule we talked about? Because of that, you have to conduct regular gas testing. Crucially, you must keep all vehicles and all that heavy excavated soil as far away from the edge as possible. The sheer weight and vibrations will trigger a cave-in if they sit right on the lip of your trench. Every single precaution here directly neutralizes one of the fatal hazards we just went over. I want to leave you with this final thought for today. In excavation, gravity never takes a day off, and neither should your safety protocols. The Earth is incredibly patient, and it will always find the weak point in your defenses. So, ask yourself, the next time you authorize a crew to step down into a trench, are you absolutely certain you've accounted for every hidden variable? Or are you just trusting the dirt? Thanks so much for joining me on this explainer. Stay safe out there.